Brian, you know you're up first.
Yep. Can you hear me?
Yes, we can.
Good.
Kia ora everyone, and welcome to TeachMeetNZ presents Teach Meet style session. We've got a great range of speakers tonight. In the interest of time, we're going to kick on. We were a couple of minutes late due to a slight technical hitch at the end there. So I would like to welcome Brian Ricketts, who is presenting all the way from Italy today. Take it away, Brian.
Hi guys. I guess good evening. It's morning here in Tuscany. I'm a geologist, and I expect you'll detect some of my biases as I go through my 5-minute ramble. Anyway, I'm going to put up the screen share. Here we go. Right. Okay. So I guess as a kid in primary and intermediate, and this was sort of late 50s, early 60s, which kind of gives away my age, I guess. But I have very clear memories of being outside, having classrooms outside, little trips here and there. Sometimes they were big trips, factory floors, beaches, whatever. They left.
Sorry to interrupt you, Brian.
Yep.
But we can't see your screen.
Oh, I thought I'd shared it. Hang on a sec. How's that? Can you see that now? Can't see that now. Okay, can you see that?
Yep, we can.
Okay, well, that took 2 minutes. Okay, so basically, I guess the reason for wanting just to make a bit of an emphasis on teaching outside is that it basically forces one to come to grips with all the dimensions that we sense. There's the 3 dimensions of the obvious dimensions plus the 4th dimension of time. Forces you to imagine in your mind's eye what you may not be able to see. So you might be watching, you may be looking at a hillside and wondering what's in it. You may be watching a bird diving into the water and wondering how it folds its wings. These are all pretty important attributes that we need to come to grips with. And I think being outside rather than being inside is the place to be looking at this. So if I can go to the next slide. I've got 4 grandchildren, and whenever they visit, I haul out my cheap 4-inch reflector telescope, and we look at the sky. The very first time I showed a couple of the youngest kids visions of the moon, so that they could see craters and shadows on craters, things like that. We also are able to see some of the moons of Jupiter and the rings of Saturn, and it just blew them away. We could have shown them pictures, digital pictures or books, but I think just setting up the telescope presented to them something that wasn't just sort of intellectual and visceral. It was quite a visceral experience for them. And I think this is what being outside does for anyone. It just expands your senses, expands your ability to explore pretty well anything and everything. So a little while ago, I created this image for my own website, and basically I put it up as a kind of, I guess, a help for anyone going to the beach if you wanted to talk to your kids about some aspects of science. And this kind of incorporates pretty well everything you could see or do at the beach, any process, any objects, any landforms, whatever. And of course, it doesn't have to be a beach. It could be a river, It could be a factory floor, an art gallery, or another lab somewhere. Basically, getting out of the classroom and looking at something like this just presents to you all sorts of opportunities to look at science in a very broad sense. There's all sorts of things going on here. Now, one of the problems with being outside or going outside or organizing a trip in school is, of course, that there's always going to be conflicts with other courses, especially when everything is so tightly timetabled. So the next slide basically superimposes some stream of consciousness kind of thoughts on the previous one, and tries to line up some of the different science aspects of science, the different disciplines, if you want to call them that, in relation to what we can see. It's sort of an attempt to think of going to the beach or going somewhere, anywhere, even the playground, and looking at things, but not just sort of going out and looking, say, at geology, but going and looking at every other aspect that of science that you can incorporate into it. So if you go to the beach, you might look at the waves. You can incorporate maths and physics. You can incorporate art and language and describing in prose or poetry or whatever. You might even want to look at cultural history in relation to waves. There's environmental aspects, there's human geography, there's pretty well anything you want. So you don't have to go to the field and look at any one thing in particular. You go and you organize it so that you look at a bit of everything. So if you go for a morning somewhere, you might have your own class, and there may be a maths class or an English language class or something. So basically organize it so that you incorporate those aspects of the curriculum into the trip. I don't think this is anything new to anyone, but I just thought I'd like to emphasize some of it. And especially, it's somewhere like a beach. There is so much that you can see, so much that you can look at in pretty well any aspect of science. The chemistry of seawater. If you've got a more senior class, you might want to look at the pH buffering in relation to carbon dioxide and climate change and everything that goes along with that. There's just so much that you can get out of being outside the four walls of your classroom. That's basically it. Yeah, I've probably gone over my 5 minutes, but there you have it.
It wasn't too bad in terms of time. Are there any questions? I think we probably all agree that experiences outside the classroom are really, really important, but they're getting more and more heavily legislated, which means it's more and more important to try and go on them because those opportunities are becoming less.
Yeah, I'm well aware that there's all sorts of issues like health and safety, and apart from the timetabling, which isn't a trivial matter, but one of the excuses, though, that certainly when I was teaching at university, one of the excuses was that there was always conflict, and it was just a huge battle, even at university, to organize a weekend field trip somewhere. Students were either working or had other courses, and and yet without it, the students just weren't getting as far as I'm concerned, weren't getting a full education. So,
just a quick question from me. I'm Tony. I think that biology particularly can benefit from these field trips, and I'm planning one at the moment for Soames Island. Have you any advice in terms of the field trips and what gets the most out of it for the students?
I think one of the things that always struck me, and this actually applied even when I was teaching at the university, the students, I think, rather than just focusing on one specific problem or one specific topic, actually a broad look at a number of different aspects of the science, not just related to your biology, but perhaps you're going to an island, so there's seawater around it. How does that affect? How does the weather affect? Just things like that. That I think, because your students will all have slightly different interests and focuses themselves. Some will like the bio, and some will like the geology, and I hope anyway, some might like just to go for a swim. So why not look at the dynamics of waves in relation to surfing? There's lots you could do there too. So I think just keeping things quite broad. From my perspective anyway, that's always been quite successful.
Thanks a lot. That sounds great.
Cool. And Charles, are you good to go?
Yep. Hopefully. Cool. As in, I should start now?
Please do.
Okay, cool.
Sharing your slides for me, please.
I'm sorry?
Just double check when you share your slides that you've got
Yes.
them on the front of your screen.
Absolutely, I'll do that now. Okay, good everybody. So I'm actually not a teacher currently. But I would consider myself an educator. I worked for the EnviroSchools Foundation for a number of years, and have been very involved in community development and youth development for the last almost 10 years now, I guess. So I'm currently working for DOC, but I'm speaking about today about, I guess, my own views from my collective experience on working with young people in the environment. Can you see my screen? Can someone audibly tell me? Okay. Oh, wonderful. All right. So I'm going to talk to you today, and I'm going to race to try and get through all my material about ecological education. And my focus is on citizen science. So Tony, I'm sure this will help to answer the question that you just asked as well. Okay. So I'm really interested in citizen science, as in how do we engage young people in communities and asking scientific questions in the landscape through engagement approaches and technology, and supporting them to learn how to ask landscape questions, because it's interactive and engages curiosity, so it's a great way to connect with people. It's in, about, and for the environment. I don't know if you teachers use those terms anymore, but I'm sure you do. There's endless technology that you can use in the data collection that I'll talk more about. It's about creatures and critters. So which young person is not intrigued by some creature or critter, whether it's a cute one, a scary one, an ugly one, a slimy one. It's about active citizenship. It engages our communities in the management and of the world around them. It's place-based. I'll talk more about that. It's got a community development function, and it's actually real science as well. So that's a big plus. This is a snapshot from a BioBlitz that we did earlier this year at Kaiti Beach in Gisborne. So working with the YMCA holiday program and the Gisborne homeschool community and the local environment centre, Doc ran a BioBlitz where we set up this little base station here. We had iNaturalist on the computer there. We had ID guides, books. We had Doc staff there and other people who have been very involved with restoration. And the guy in the blue t-shirt with the glasses, he was a volunteer who was really active in the iNaturalist community. If you don't know what iNaturalist is, you will soon. So we had these kids all out with adult supervisors, putting quadrats down on the beach and identifying creatures in them, looking for insects, identifying plants, learning how to use the microscopes, all that sort of stuff. This is a card from a tracking tunnel that I'd set up a couple of nights before, and you get a bonus point if you can tell me what those footprints are. When I get to the end, I'm not going to tell you what they are. But so pests and predators is a really cool way, because kids are really interested in that stuff. Tracking tunnels are really easy to make or buy, but very easy to make, and you can get that info off the DOC website. place-based approaches that involve young people and communities are just an excellent learning environment. So this is a little dock reserve on Riverside Road here in Gisborne, where we've been working with a whole range of different partners. So the fence was built by the EIT, the local polytech, their fencing studies students. We've had schools in there planting and learning about stuff. These guys here are young people from a YMCA youth development course. And they're making tracking tunnels, and we've been working with them to use apps to track, find out what creatures are in there and track them and all that sort of stuff. And so in doing this work, we can use our phones and tablets, we can use cameras, there's various apps we can use, we can learn about GPS, we can use infrared technology, we can learn about spreadsheets and data recording, we can make tracking tunnels, we can use mapping apps or learn about physical mapping. We can make artificial habitat, we can use compasses and outdoor gear, we can test different traps, nets, decoys and lures, learn about microscopes. So you can see it's a rich science learning environment. So the mapping thing, this was an interesting project that happened right at the top of the East Coast in Te Araroa, where Ngāti Porou, dock staff, Heritage New Zealand and LINZ worked together with the kids from the local schools to map an old PAR site, and they learned about Google Maps and mapping technology and also traditional mapping techniques. So when we're in the environment, we're not just learning about science, we also have a chance to learn about history and also about mātauranga Māori and how to have different worldviews when we look at the natural world. So this is Nick Tupara, who's a very talented Gisborne artist and historian, talking to us at that same BioBlitz about the kaitiaki that Ngāti Onioni understand live in the harbour around Gisborne, and so we had that layer of context and learning for the community as well. So we've all heard that term education for sustainability, but I hate the word sustainability because it's just about keeping things the same, and that's not how the world works. So I want to talk about education for anti-fragility, how we use all these approaches to engage our young people in asking questions, responding to change, thinking about how they can build stronger selves and stronger communities and stronger approaches to the world from change rather than just trying to keep things the same or bouncing back. So, and all of this means that when we look at landscapes and the world, we increase our ability to use science, which this is why we're here, to learn about science, but also I think it's really important, particularly in a New Zealand context, when we're trying to have a culture that's based on biculturalism, that we're able to look at landscapes not just with our science eyes, but also with our spiritual eyes and our cultural eyes, and and see the layers of meaning and the layers of history and ways of connecting and interacting with the world that are there. So being a scientist does not mean that we're a materialist, and this is a personal point for me that I just wanted to use this opportunity to share, that we can use science, it doesn't mean we have to dismiss things that we don't yet understand. And I think in working in a bicultural environment, and if we're working with Māori young people or any young person who connects with the world spiritually, we don't have to, we can have both of those things, and it's called pluralism, and Darwin was a big proponent of it. And so thank you, that was my presentation.
Thanks, Charles. That was awesome.
Cool.
We had some votes from the YouTube feed that it was the possum or hedgehog prints.
Okay, so, well, I want to ask you a question. Is a possum likely to walk through a really, really small little tracking tunnel that's too small for it? So the answer is yes, it was a hedgehog, so well done.
So well done, Diane. It was Diane that got that one right. We won't out the people on the DHO chat.
but yeah, I didn't specify the tunnel, so that was that was a fair guess.
Cool. Any other questions there? Just quickly, because we are sort of motoring through time.
Yeah, I had a whole lot of websites to show you, so I probably don't have time to do that, but
We can pick them out and put them on the blog.
Yeah.
iNaturalist is a fantastic website.
That's very useful. Thanks very much. That's very helpful to me and my quest. Thank you.
Cool. And I know heaps about Matu too, so happy to email you or for you to email me.
Oh, I'd be overjoyed about that.
Yeah, well,
I'd be absolutely overjoyed.
Yeah, you contact me and I'll
useful.
get back to you.
Thanks so much. That'd be great.
We've also had Michael tweet out Gizzy represents, so that's pretty cool. We've got 2 Gizzy people here, so I'm stoked.
Cool. Andrea, are you good to go?
I'm good to go, yeah.
Perfect. Then over to you. Thanks very much, Charles.
Yeah, well, how do you follow on from those 2 talks? And hopefully mine will be resonating in the same sort of light. Absolutely, Afi, everything that Brian said in the first presentation, and also what you said, Charles. Yeah, thinking the same things, talking the same stuff. So let me share my slides. And there we go. Hopefully you can see that. Great. I do want to share a little bit of talk about the power of experiential learning. And I want to share with you my journey to the Subantarctic Islands, which I was very lucky to get to go down to the Auckland Islands last November with Doc, with the Yellow-eyed Penguin annual count. So absolutely an amazing experience. We were there for 2 weeks, and this was a shot leaving Bluff. Challenges were, I've never actually been, I go fishing a lot, Raglan, Coromandel, but this was a completely different experience, leaving the bottom of the South Island, heading out 465 kilometres off the bottom of New Zealand South Island. For me, the challenge was really not seeing land at all. And of course, hanging out in a 25-metre yacht with 12 people, which I'd only just met in very close quarters. The trip down was absolutely spectacular. In fact, the crew said it was one of the best trips I'd had weather-wise. Absolutely beautiful. Of course, it wasn't always like that. 6-metre swells coming back wasn't as pleasant. So the Auckland Islands are spectacular. They are an absolutely beautiful environment, but extremely harsh. So it rains there 25 out of 30 days of the month, every month, all through the year. Cold, windy, but again, absolutely spectacular. And there's the yacht where we slept, ate, and did a lot of our work on, and everywhere you look we're surrounded by wildlife, and there's some sea lions there just from looking at us on the inflatable. Of course, yellow-eyed penguins. This was on Enderby Island, pest-free. Absolutely amazing to get to see these animals in their natural habitat without pests. And this is just a beautiful shot of them looking over to the yacht. These are adults. You can tell that because there's the yellow part goes right around the back of their head there. Juveniles don't have that fully formed yet. Wildlife is, I still just get blown away by the amount of wildlife and how close you can get to it. These albatross were just absolutely spectacular, and you don't really get a sense of how large these animals are from this photograph, but they're absolutely beautiful. Again, you know, lots of penguins. For me as a biologist and a teacher, going to the Auckland Islands and on the yellow-eyed penguin count, I got to actually do some real field work. Doc had a really neat methodology. Oh, when I say neat, I meant robust. The methodology was we count from 5 a.m. in the morning till 9 a.m. in the morning. We did that most days, weather permitting. We could only count penguins that entered the water or exited the water. Of course, there was a lot of penguins which came down to the water and would assess whether or not they jumped in or not, and some didn't. Some went straight back up into the bush for various reasons. But that was part of what I loved, was that I was out there doing it in the real world. And you can see here the Southern Ocean just at its harshest, huge kelp in the background. Everything is large on the Auckland Islands. And kakariki, which are absolutely amazing. I have not actually seen kakariki in the on the mainland in the wild. When I worked at the zoo, I bred them prolifically, but was just an absolute buzz for me to see them in their natural habitat, and that it blew my mind. Every day it was like I was on a sensory overload. There was so much to see, so much to do. It was just mind-blowing. Gorgeous little elephant seal there, just hanging out at the beach. It's this is what you come across when you go for our little adventures and walks after we've done our field work. And the sea lions are just amazing animals. Of course, they were a major hazard, and they are very aggressive. And I mean, in this photo, they do rush at you, and a bite from a sea lion is quite dangerous. In fact, it's probably you know, a helicopter can't get to the Auckland Islands. They've got to stop halfway through onto a ship to refuel. So, you know, you're kind of in the crap if you get hurt a little bit. When we think about health and safety, Yes Doc had a very strict health and safety kind of policy and guidelines when we were down there, but actually the risks we took were risky, and I just loved it. It puts you out of your comfort zone. And this photo is of the rata bush. So basically rata is the only large tree on the Auckland Islands. And when you look up, this is the view you get. We weren't there, or they were just about to break out into flower when we were there, but I'd imagine in summer it would be spectacularly just covered in red. Absolutely amazing. Some more views from some of our treks that we went up to. For me, it was just mind-blowing. This photograph looking straight down into the Southern Ocean, full of absolutely magnificent animals. Great white sharks, didn't see any of those, unfortunately, but magnificent animals we know that are there. Lots of sea lions. Just an amazing array of wildlife. Of course, you know, the people are great, and there's a huge amount of history or historic stories around how people have tried to live on the Auckland Islands. There's been a lot of lives lost on the Auckland Islands. For me, I found that really interesting, but not as interesting as the wildlife I saw and the adventures I had. But that's just me coming from a true biologist point of view. The people, though, that I went with, absolutely spectacular people, solidly grounded, absolutely passionate about what they do. And I just absolutely, you know, we arrived not knowing each other. We left as sort of lifelong mates. Absolutely amazing. Just some more images. Of course, living on a boat. Hugely challenging, trying to pour a cup of tea through a tea strainer while the boat's moving. Just, yeah, I can't describe how challenging some aspects of these 2 weeks were. Absolutely no contact with home. We got partway into our trip when we heard about the Kakura earthquake. So we actually really had no idea heading home what we were coming back to. We got snippets, of course, and we had a satellite phone we need to ring into, but it was just quite isolating. But that was really refreshing in some ways. What I really want to get across here is that we actually are all learners. There are lots of opportunities for teachers to go and extend yourself, to take up those fellowships, to get out there and experience life yourself. What I want to say is, take those experiences, tell those stories, be passionate and inspire your students back in the classroom. Understand the power of experiential learning. I am a real advocate for environmental education. I've breathed and lived it and experienced it and taught it, and for many, many years. They are opportunities where you can create significant life-changing teachable moments for your students that they will remember for their lifetime. And it's not that hard. You can do this outside the classroom, inside the classroom. It can be done. So take the risk. And it's actually teachers that should be pushing those boundaries, not the other way around. Our students shouldn't be pushing them. We should be pushing out those boundaries. So just what I say to you is get amongst it. Take those opportunities to hug a tree at least once a day, and just take on the adventure and run with it. You will never, ever look back. So that's it. That's me. I will pull everyone back up again. Oh.
I think there was just an overwhelming feeling of envy there. That's amazing. Time for one quick question while Emma gets set up.
Oh, I have a question about the kakariki. Yeah, like were they bigger than the New Zealand version, or just
no,
still the same size?
Yeah.
Were there any other sort of species that you noticed were larger, just being based or isolated in the Auckland Islands?
The plants certainly were larger. So the kelp was humongous. And I was over at Waihi Beach last weekend, and I was looking at the kelp there thinking, oh my God, that's so small. So everything's larger. The mega herbs are mega herbs because they have large leaves. The adaptations that particularly the plants have to that really harsh environmental conditions, the amount of rainfall, the peaty soil, is really amazing. They've all got very thick, waxy leaves. So, those sorts of things really excite me to see such a different environment, yet it's still part of New Zealand.
Oh, nice. Super jealous. And I can't talk, but yeah, it just looked amazing.
Yeah. And there are opportunities through Sir Peter Blake Trust, have teacher fellowships who get to go down to the Auckland Islands. Yes, you're chaperoning 30 young people, but absolutely amazing. So do it.
Do they need young people? I mean, do they need us, young people? Do they need chaperones?
They do. I've chaperoned the Sir Peter Blake Yelf Forum for the last 6 years. They do ask for chaperones.
Yeah, cool. Oh, that's good to know. Yeah, I mean, the experiences that I've had with Yelf are just very memorable. Just
Yeah. I remember your talk, Emma.
True.
And I was saying, oh my gosh, I'd love to go. Yeah.
Awesome. Okay, I better click on.
All right.
So,
thank you everyone for letting me share.
Kia ora. Me. Okay, so I will flick on my slides. I was going to do my timer, but now knowing that I've got an extra little bit of time leeway, I'm going to click my slides. So I've just realized I haven't shared. Pop that down. Okay, are we all good? Okay, cool. I can see Chloe saying, cool, good. Right, we'll load those up. Okay, so I'm Emma McFadden, and I currently work in Gisborne 2 days at a school at Te Hapara. And I'm a specialist teacher, and I focus on areas of science and math. I have to click, I'm not used to it. So this story is about my exploration into play-based learning, and at the moment I'm studying a postgrad certificate at the Mind Lab by Unitec. One of our flipped learning tasks for the Mind Lab postgrad was to investigate a computer game in relation to problem or play-based learning. Now, not being a computer game person, or that I associate myself with, I turned to a gamer friend who recommended the game Monument. Now, the game oh, I have to click again. The game is value-based and hooked me straight away. When showing him my enjoyment through social media, I ended up sharing some misconceptions I had between game-based learning and gamification. And I was told of my misconceptions, which to begin with stifled my wonder and inquiry into the new learning. Now, it ended up changing my direction, and then I started to wonder about the stifling feeling and if this is what it felt like when we tell kids. Now, how many times had I unintentionally killed wonderment and exploration by simply informing? This led to an investigation in play-based learning. Now, my previous perceptions of play-based learning were setting up some centres and giving students the opportunity to explore and engage from each other. After some research, I learned in addition to this, it's an optimal context for learning that uses an inquiry approach and promotes self-regulation and direction. I then wanted to find out my role as the educator in the process. So in my view, I found out that it was a hands-off inquiry approach with a strong direction into the art of questioning. I thought I'd attempt my inquiry with the juniors first. So through that, each week I was in the year 01 learning space, and I brought a new hands-on learning activity relating to the nature of science. I worked with students listening to their stories and would probe their learning further, and in some cases bring to light misconceptions through questioning. And I've got a little video here, which I can play for you.
Where does the ear come from? The ear comes through your mouth into here and then up. Look at my bubble.
And where do you get the ear from? How do you get the ear?
From the sky.
I love that. Okay, this led to using similar techniques with the senior students, and I wondered how I could bring elements of play-based learning to the activities we were doing to invite similar inquiry. In this lesson, we looked at variables by adapting an experiment, but had flexibility by applying the play-based learning principles. I'll flick that through.
I wonder what's happened. Why do you think that it's not working the way that others have worked? Was there something that was happening in the back?
No, you have to, it's not green. It's not green.
So the back hasn't been sealed.
Okay, so yeah, in reflection, the things that I've learned through that inquiry, or my personal inquiry, was to hang back and chill out and listen to my students. They have brilliant ideas about our world and are experts in their own right. I just quoted, of course, we get air from the sky. So I thought that was a little gem. But also even today, I did some work around Maui as a scientist, and we explored that concept. And the understanding that came from that was magic as well. I've got utilise class and student dynamics, get them working with and off each other, which furthers that self-direction and regulation. As well, we always, just to always challenge my thinking and perceptions, seek clarification by questioning to avoid those assumptions. Often, again, it comes to just hang back and just listen. And also my future goal would be to explore innovative ways to introduce aspects of play-based learning, and also explore that game-based learning with senior students. And just, yeah, I think that we do a great job of play-based learning at those lower levels, but then, yeah, bringing it into the senior area is something that interests me especially. So kia ora, I will delete and stop sharing.
Awesome, thank you.
Okay, cool.
I'm going to keep being organising. Jenny, if you want to get ready, if we've got time probably for one quick question, if anyone has one.
I sort of do. How hard was it to step back? You said sort of chilling out. How hard did you find that?
I suppose I'm not in the classroom full time, so there isn't that sort of assessment drive at the moment. I'm constantly assessing, and there's those observations. But yeah, I suppose, you are always assessing. I don't know, I think because this was my inquiry and that I was, that's what I was wanting to achieve, that was my focus to step back. And so, yeah, I think just having that mindset, I was able to achieve that. And then just, those gems, hearing what the kids were saying, you're just like, oh, they have that understanding. And just even, that question, just to push them that little bit further, I mean, they got it straight away. So, yeah, that was the magic, I think, and the realization. So that was quite powerful.
So with your question, did you aim to correct misconceptions, or did you let them explore that as far as they could take it before challenging it?
Yeah, both. I think it was, like, to begin with, probably trying to clarify misconceptions through the questioning, but then that was, again, my perception. So to pull back and go, okay, look at this bigger picture wise, these kids might have it and it might actually just be me thinking they don't. So again, yeah, that was the learn, or the power of the learning behind it, was to see that, and then again question from my perspective to clarify what it was that I was thinking. If I've explained it well.
I think so.
Yeah, yeah. So it was more to seek understanding around my perception, and if I had it correct, and if not, then yes, probe further to see what, I suppose, the mutual understanding. Still learning, Maddie.
Hey, same. I mean, there's a comment up there. It's something with what we're doing in one of our courses at the moment. I'm having to learn. We're putting ourselves in a lower status than the students are the experts, and we're not. And it's like, it's so hard, particularly when you go into the laboratory. It's like, I'm so used to being seen as the expert here, and I have to treat them like the experts. So that's why I asked the question, because it's like, I know how hard I found that this week. It's been, catching myself out more than being proud of myself.
Yeah, for sure. I think you've nailed it there. That's that, coming at that sort of lower level.
Yeah.
Sure. Yeah, it's that power, that power, not power struggle so much, but yeah.
Dynamic.
Creating that. Cool. Okay, Jenny.
Right, is my microphone working?
Yes, it is.
Okay, yay, that's good. Hi everyone, I'm Jenny and I'm a primary teacher in Christchurch at a brand new school, Lemonwood Grove. We just opened this year, so it's been quite a whirlwind journey. But I'm going to talk to you about a unit I did with my previous school last year, and I'll just get it going. So. So we were doing a unit on creativity and getting the kids to explore what it meant to be creative, and we did all sorts of things, like we Skyped composer friend of mine, and we Skyped Susie Wells and asked her what she thought creativity was in science, and did all sorts of things like that. And on the science side of things, I was getting the kids to understand sort of what the mystery of science was, and then use creative thinking to solve different problems. So one thing I found with our students was, how do we teach the students to embrace not knowing the answer? There was a lot of kids who had to know the answer at my school, and they didn't like it when we didn't know the answer, or they found it so easy to Google things in this day and age that they're so used to getting the answer. So it's a challenge when actually you might not be able to get the answer. You might just maybe know something. Sort of like a lot of things in science, we use a lot of evidence and we kind of know things, but we don't 100% for certain know that it's definitely true. So through this creativity unit, my skill focus was on teaching them a bit of the difference between observation and inference, and how to solve problems in a creative way. So I took that through starting off with looking at the problem of tricky tracks, and we were really developing their observation and inference skills. So if you've never seen this before, this is the idea of what's going on in this picture, and then giving them a little bit more information, and then giving them a little bit more information. And the discussion we had around it was awesome. There was lots of really good ideas coming out, and they really got the idea of what an observation was versus what was an inference. So basically an observation on this was there are black marks on the white surface versus those are footprints from a bird. We don't actually know that definitely. Then I moved on and we started with mystery boxes, and I had a series of different boxes that were covered in black plastic, and the kids had to try and figure out what was inside them based just on the sound and the feel and the movement of what was going on. And so they were using some inference skills alongside their observation skills. And once I built up all of those skills, we then moved on and we looked at the mystery tube idea, which is where you have a series of strings that you pull and something's going on inside the tube. And when you pull one string, a different string moves every time. So the kids then drew their ideas and tried to come up with different things of what they thought was going on. And then their next step was they actually started constructing it themselves and having a go, and they had to discuss their ideas with a partner, and they had to try different things out. And there was a lot of frustration, which was awesome. And not every kid got the answer. And my biggest thing was I never let them see what's actually going on inside my model version. I did a lot of talking around there are lots of different possible solutions, and are you wrong if it's not exactly the same solution as mine, versus if you get the same outcome as mine, you might be right. And then their final big project was the mystery bucket, which is the one where you pour in different coloured liquids into the bucket and clear water comes out. So you might pour in some blue water and clear water comes out. Then you might follow that up with some red water and blue water comes, clear water still comes out. So then they watched a demonstration of it, and then they had to go off and plan and make diagrams and then make models and try their own versions out to see what would happen. And we got so many different cool ideas going on, and success and failure and all sorts of different ideas. And the really great thing was that the kids could see that so many different people had different ideas around what they were doing. And nobody was upset by the fact that they might not have been successful in solving the problem. But they all got to have a go, and they got to chat, and through all this you can see all the different types of bits and pieces that they did. The biggest thing I got out of this with the kids was the conversations we had, and there was a lot of challenging of each other about how do you know that that's true and why do you think it's happening. And there was a lot of different skills that the kids were using. So they were using their observation to watch my demonstrations in the first place. Then they were taking those away and trying to recreate what they saw, and they were coming up with different solutions and all sorts of things. And there was a lot of scientific skills going on, and the kids really, really enjoyed the whole spectrum of things and got a lot out of it. So that's what I've got to share with everybody, and I'm open for questions. And my screen share is not going to go off.
Oh, I have a question.
Yep.
Be jumping in. But did the kids kind of had like a fail forward mentality before doing the project? About how like there was that acceptance around if things didn't work out, or do you think it was the project that instigated that?
We've been doing a lot around grit and growth mindset during the year. So we'd done a lot of talking with the kids around how it doesn't matter if you fail, it's a part of learning. So yeah, but I think also they also knew me being the scientist. I didn't ever let them know the answers. I'm I'm a bit mean that way. I refuse to let the kids know what's going on. Like, here's my mystery tube. So just so for everybody to see what's going on. But the ends are always sealed, and I never let them see inside it. So there's a lot of frustration. There's a lot of kids going, I want to know what's going on, and I refuse to do it, and they have to figure it out. And some of them, it took them a couple of weeks before they even figured it out. Some of them just kept going and going and going.
Yeah. Oh, cool. Yeah. Oh, that's awesome.
Yeah.
Have you got anywhere? Are they sharing any of that learning online, or I mean, it'll be to show that to some of my students to say, hey, you know, these kids are persevering, or.
No, we haven't, and I've moved away from that school now, so I haven't still got the students.
Oh, you do?
Yep.
Right, especially all that mindset stuff.
Yeah, definitely. Cool.
Awesome, thank you. Dave, are you good to go?
I suppose so.
Thank you.
Hi, right, screen share. And share this on screen. Okay, play. Okay, so I guess you guys can see that. I can't see anything else on my screen, so I guess you're seeing it. My name's Dave Warren. I'm from the University of Otago, and I want to share a little experiment we use in the chemistry outreach program down here when we're working with intermediate kids, year 7s, year 8s, particularly year 8s. And it's a little bit about the nature of science, but it also sort of talks about showing kids why scientifically you need to be honest in your results. And the secret of this works a little bit like Emma was talking about with the way you question the kids and the way you put it. You don't come across as the sage on the stage or the fool on the mule or whatever you want to call it. So anyway, let's get going. So it's an experiment a lot of people will have done before. We call it the 20+20 experiment, which is basically 20+20 makes 40. So what we do is we get the kids to measure out 20 mils of water. We get them to measure out 20 mils of canola oil. We put a little bit of green dye in the water because we find it's a lot easier to see the meniscus when we do that. And we really focus on what does the meniscus look like. So we use iPads or phones to use as magnifying glasses so the kids can really see, rather than just saying, yes, we can see what you're pointing out when they really haven't got a clue what you're pointing out when you're trying to point out a meniscus. And it's all about training them. We tell them we're training them for a skill. We're training them to measure liquids and use these measuring cylinders, which they've never used before. It's really important that the class results go on a board, if you still use boards in your classroom, whatever the modern version of a board is, but we put it on the board. And we also tell them that they've got to do 3 times. We tell them initially that they're doing it for practice so that they can practice their skills. But in reality, what we're trying to do is generate a little table like this, where we end up with a set of experimental results that have all sorts of varieties in them. So we've got group 1 at the top there, where we've got pretty consistent results, but there's a bit of experimental variation in there. We can talk about why we do averages. We can talk about anomalous results like the ones that are crossed out. We can talk about why 39.0 is better to read than 39 when you're using a measuring cylinder. We can talk about why people putting the units in the tables aren't necessary because we've got them on the top. And in this case, we could probably have talked about what the heading should be from the columns. At the moment, fairly standard and fairly standard way of operating in a classroom, I guess, when you're trying to do this sort of stuff with kids. The next bit, though, is where the questioning starts to come in. And also, like Jenny was saying, they don't know what the answer is for the next bit, and we don't tell them what the answer is for the next bit. We let them discover it. So what we're going to do, the next bit is we say, okay, you guys have had lots of help. You've managed to get we're happy with your skills. We sometimes give them a prize for being able to do things. We give them a certificate or whatever. At this point here, though, there's a definite competition or an emphasis on them getting things right, whatever right means, but they don't understand that at the moment. We put in 20 mils of water. We put red food dye in with the methanol. They measure out 20 mils of methanol. We set them a question such as, who can get the best answer, who can get the correct result. We're trying to focus them on the idea that there is a correct result and they get hung up on it. We offer them a little prize, could be house points, could be chocolate fish or a balloon fly of dry ice, which is the sort of typical bribe we use in our work. They put the results on the same board that the water results are on, so they can compare them side by side. You don't give any help. You just stand back and watch. And if you've got a camera, it's quite interesting. We get a picture a bit like this, a board a bit like this picture, which is not a very good picture, but it's the best one I could find. The top 3 lines are the water results, and they can see the black line in the middle where they averaged. Some of them have been a bit enthusiastic with their decimal places, but they're pretty consistent and they're pretty good, and they're fairly typical of what you get when we do this with our Year 8 kids that we're normally using this with. Underneath that, there are 3 lines that have got the methanol results, and if you look at them, if you look at the averages, you can see the bottom line, the first 4 groups, they're pretty consistent. They've got less than they got for the water, which is the sort of thing you'd expect as a scientist, but for these kids, they don't know whether that's correct or not. The second 4 groups have actually got averages that are the same. In one case, one's a little bit more than it was for the oil and water. And at this point, this is where you start your relationship with your class and how much you can trust them, and you start talking to them about, well, hang on, half the class here have suddenly got a different trend to the other half of the class. One half of the class isn't getting it right. Which half of the class has got it right? And if you've made some observations, you can throw in points in here like, why were you doing that when I saw you doing this? And the 3 common things that you're going to see with the kids that are getting the same results as they did with water are things like they'll top up their cylinders. They'll look at the number. It'll come out. It'll be 38.5, 39 mils. They just add a few drops because maybe they didn't measure it properly. Some of the groups will use those lovely skills you've just taught them and use the top of the meniscus instead of the bottom of the meniscus because it's closer to 40 mils. Other ones will actually change the whole question. If the original question was, what does 20 plus 20 make? They change the question in their heads to, how do I make 40? And they start adding 21 mils of methanol or 22 mils of water. They want to make 40 because they expect 40 to be the correct answer. So this unknown thing, kids get really wary around what's unknown, and we don't know what to expect, and we don't trust ourselves. You guys are the big scientists, and we're looking like idiots in front of you. There's all this sort of stuff comes in. It's really interesting to look at. And of course, the whole point is, when you're a scientist, you publish your data, you share your data all over the world. If you cheat or misrepresent your data, or you manipulate your data, or you present data that's not correct, or you use data to show 2 trends that are contradictory in 2 different papers, someone somewhere is going to try and simulate your results, and they're going to get it wrong. They'll pull you up and haul you over the coals. And eventually, we get cases like these things, which are taken from retractionwatch.com, where you get these huge $200 million research cases against Duke University, big prestigious university. And you can talk to the kids about, why do people do this? And at the end of the day, it's to do with scientists who get a lot of prestige. You can get a lot of money if you get a professorship in some of these big universities. You have huge careers. You're lauded and feted around the world. So the temptation to actually do it wrong is huge on some universities. Some universities put a lot of pressure on their scientists to be publishing in the top journals all the time and producing the top of the range research. Puts a lot of pressure on them. Occasionally, people take the wrong option. It could make, if I was doing this in high school, because I was a high school teacher, I'd probably be looking at this as some sort of homework, as a follow-up on this and a little case, because some of these cases are really intricate, but some of them are quite straightforward about how they've cheated, what they've done, how they were caught out. And 9 times out of 10, the way they get caught is either they try and repeat the data by somebody else tries to repeat the data and prove they got it wrong, or every now and then one of their own research students will dob them in because they realize their boss has been cheating, and their honesty comes out, and they rat them out of some sort. And then finally, you can go back to the discussion around science about using a theory to explain your results. Why do the results come out at 38.5 or whatever it's going to be compared to 40? You can look at particle theory of matter. Sometimes the kids will see the oxygen bubbles coming out when you mix the methanol and water, and will feel the heat, so you can generate a discussion around that. And then, of course, a really important bit of science that comes at the very end is, well, we've seen this once. Does that happen all the time? Because if it doesn't happen all the time, maybe we've just discovered something unique. But if we want a theory like we're basing these 2 little diagrams on, we need to do it again and go over the whole thing all over again with a different set of liquids to see if we get the same trend. And that's my talk. I hope that worked. So did that work? I couldn't see a thing.
It did work perfectly.
Thank you. That's good.
We're running a tad late. Sorry to people on YouTube. We're going to push through in that. Nickel, are you good to go?
Yeah, happy to go. People are happy to stay late. So.
If anyone's got maybe one quick question for Dave. Okay, we'll just push on to Matt. There were comments on the YouTube feed, Dave, so I'll feed them to you. I'll flick you an email.
Before I start, I'm just going to make a comment as well. Dave, I love the process of that. I love that you got them working collaboratively and then competitively, or in an authentic setting, and then taking it even further than that and talking about that cheating and so on. It was, yeah, I love the process. A lot we can learn from that. Right, going to give this a shot and see how we go. So, if someone who's got their microphone on can tell me if you can see the first slide. Should be coming up now.
Looking good, Matt.
Sweet. Okay. Kia ora koutou. Ko Rolleston College Haureka Haumata Te Wahimahi, ko Matt Nicol toku ingoa. Tēnā koutou, tēnā tātou katoa. Matt Nicol from Rolleston College. We're a new school this year, only year 9, which is very fortunate. And doing things very, very student-centred, even so far as our school rules are sort of still being developed with our learners at the moment. So quite an awesome place to be if working with students and giving them a lot of agency is something you're excited about. What I'm going to talk about, though, is not about how the school runs, but about a course that was put together that I had the pleasure of being able to teach last term, which is called Proof. First of all, though, a bit of a background about how we run our timetable, because this has actually allowed us a lot more flexibility. Our timetable is broken down into 3 100-minute blocks. Our core is sort of like form time or tutor time on steroids. It's where we do pastoral care, academic care. We also do inquiry processes and that sort of thing, and a thing called quest projects, where they get at least 1 term of those. And we also do Rolleston Reads, which is sort of a literacy, reading, blogging type thing, and a few other bits and pieces in there. Connected learning, CON, is where science, maths, English and social studies always live, and 1 other learning area per term over year 9 and 10 to make sure that we have full curriculum coverage no matter what selected or option subjects learners take. Proof is a selected, so I had them for 2 100-minute blocks per week for a term, and they had 2 selecteds, so they had Proof and another one. So selected learning, as I said there, 2 blocks. We designed our initial selected learnings last term based on things that we as teachers were passionate about, and then the learners opted into those, and the ones that had good enough numbers ran and the others didn't. They were a mixture of multidiscipline or very specialized. So for example, we got Japanese language and culture, Chinese language and culture, that sort of thing, with specialized, whereas Proof itself, the one that I'm going to talk about today, while being heavily based in the sciences, this was multidiscipline. It was looking at some social studies or quite a lot of social studies and English learning areas as well. So when we set up the course, actually I wasn't part of designing it. I was just lucky enough to get to teach it. The initial designers of the course, only one of them got to teach it because of timetable constraints. And then I got asked if I would step in, and more than happily said yes. So our sort of 3-prong attack was that we were going to look at forensic science, the legal system, and the idea of justice and beyond reasonable doubt and police work and interrogation, that sort of thing. So in our planning last year, end of last year, we had to think, okay, well, where could the learners take this? What should we be prepared to offer, workshops, learning opportunities, and so on? And in the end, when we looked at the number of things there, and this was only a few of them that you see here, we realized that we were up for hiding to nothing. And the best thing for us to do was to actually see what the learners wanted to do and have a system of, or set the course up in such a way that it allowed for a lot of student agency. Then we got to see who was in the courses and how it was going to be set up. So we had 2 classes, quite big uptake for this, and there's huge demand for it to be run a second time this year. Remembering we've only got 220 learners in total, so we had 33 of them doing this course. So Kelly did the Monday and Tuesday class, and Danny and I did the Thursday and Friday course. So really lucky with our student to teacher ratio, because we're overstaffed this year. Those numbers will be more like the 1 to 25, 1 to 30 next year, depending on demand. So again, in our planning, we had to think, well, what's going to happen without a science teacher in the Monday, Tuesday course? Because we do want to make sure that forensics can be covered by all 33 learners. And Kelly, while she was very happy to step outside her comfort zone, definitely was also honest enough that she needed a bit of support with that. Well, again, it was in how we decided to run the course. We planned for it to be very, very learner driven. So they would do the research, they would find the mentors to help them. But then we also thought, well, hang on, we have to be practical here. There are going to be some workshops, some learning activities that we're going to run in the science labs, and I'm going to need to run them. So I came out of my connected learning class now and then, which was on at the same time as Kelly's class, to run some things on whether it's blood splatter or fingerprinting or something like that that was more forensic science. Or the learners came out of their connected class and joined my class and then caught up on their work in their next proof class. So they caught up on their connected learning in proof the next week. So there's a lot of flexibility, and hopefully that's the way the school's going to run from here forth as well, that we can have that flexibility to allow that student agency. So our plan was start with a crime scene. So the very first thing I did is I spent my summer holidays in heaven writing a crime scene and planning evidence that I could plant and things like that. So I got to write a play basically, and then go and mess up one of the labs completely as a crime scene. The idea of that, of course, was a bit of a hook. Also see what the learners brought with them and their prior knowledge, preserving a crime scene, any forensic techniques they currently had, and what sort of things do they seem to be really keen on and interested in. As well as that, I set up a Google site where I put all of the evidence, interviews, synopsis, that sort of thing for this crime scene, so the learners had ubiquitous access to the evidence. They didn't have to be in the lab to get it. If they forgot to collect something, it at least was duplicated online. Thankfully, I had a lot of colleagues who were happy to give up their time to be interviewed, and that was to play a role in as suspects or witnesses for the crime. Then we did some reflection on how well they thought they did on solving the crime, and they started doing a bit of reflection before we told them what really happened as well. So we wanted to see what they thought about how well they did before they knew if they were right or wrong. So they're focusing more on process than outcome. And then we told them how well they did. You'll see the use of solo taxonomy there. We are pretty big on using that at our school as a way of assessment for learning rather than assessment of learning. So this was why it was used for self-assessment and peer assessment here. This is also where we got the formal writing into our course as well. Unfortunately for our class, Danny's and mine, it was the same day they had to do formal writing in their connected class. So they were a bit sick of formal writing by the end of that day, but they were also pretty good at it. Then from the reflections, we let them have a bit of exploring. I did have that as play, but it wasn't. It was exploring. We had this website available for them. We had some videos. We did some workshops, particularly on observing, but also some simple little skills that they might be interested in, to see what they were keen on. And then we asked for their voice. And so I set up this Padlet and just said, look, put in 2 or 3 things you want to learn about. And that helped us design the rest of the course. So this gave them the voice on designing what they could learn about. Helped us get them into teams so that they could actually work collaboratively, and hopefully find some mentors. It allowed me to plan some workshops. It allowed Kelly to plan some workshops, and allowed Danny to plan some workshops on the things that used our personal strengths to support what the learners wanted to do. And it also allowed us to set up some, set the students up for doing research, to find things out for themselves, to practice it for themselves, to pitch to us what they wanted to try and do, so that we weren't running the course, they were running the course. The plan, and I'm going to emphasize, and this was part of our formal assessment, again using a solo map to plan this out. So this was how well they learnt that skill, was actually part of what we were assessing them in through the course. Then the plan, and I emphasise that quite strongly, was that we'd have another crime scene for them to apply the learned skills in another manufactured crime scene, and then ultimately in the last couple of weeks them to celebrate all of their learning in whatever way they wanted, whether it's another crime scene, a murder mystery meal for their whānau or friends or teachers, maybe bringing their whānau in and then teaching them what they learned. We weren't sure what they'd want to do. The reality, though, I'm sorry, this is our rubric. The reality was we really struggled with finding mentors, and the learners really struggled with finding mentors. So what that did is that slowed us down. It meant that we had to run more workshops and spend more time on research, which meant that we ran out of time to do a third crime scene or whatever. We couldn't do our celebration. But also what happened was we had two learners who were adamant that what they wanted to get out of this course was writing a mock crime scene. So by the ethos of the course and the school, why not? Let's let them write it. It took a lot of work off my shoulders, and that rather than me writing a crime scene that accommodated all of the skills that other learners were acquiring and learning, these two learners had to find out what others were learning and then write their crime scenes accordingly. And I just acted as a bit of a mentor to help with that writing a play, I suppose you'd say, and setting up the crime scene. And the amount they learned was amazing. So what ended up happening was that the two crime scenes ended up being our celebration. We broke my class in two. Half of them set up one crime scene, half set up the other, and then they swapped over and solved each other. And Kelly's class also had to solve them. And that was the way that we celebrated the learning of the course. And then we went back to that rubric that I had before, this one here, and actually gave them, I don't like calling it a grade, but gave them feedback on the progress they made through the course in these three areas. The last one, be collaborative, is a big deal for us at the moment because it's sort of a bit of a focus for our Rolleston spirit, so our values of the school. I'm not going to carry on because of time, but I've also, if I can share the slides through the blog, I will. I've also got some links there that are quite useful, including my own reflections on it. And then there's a whole lot of slides of learner voice from the girls who wrote the crime scenes, and one who has actually played the part of a suspect. So, as I say, I'm just flicking those rather than going through them because there are quite a few of them. And there is proof.
Awesome, thanks, Matt. And on the YouTube feed, we've had a couple of comments about the teachers, people watching wanting to do proof. So I've given them your Twitter handle and told them to get in touch.
Awesome.
And we're going to push on through, and I'll stop Tony Cairns at 5 minutes. But if anyone has a real quick question for Matt while Tony loads up his slides, I'm sorry that we have gone over time, but I think the presentations and discussions have been really good.
Can I just say that was really exciting, Matt, like just seeing what you're doing with yeah, assessment wise, that's awesome. I'm going to hassle you about that. I think I've just been writing it in the notes. I'm like, oh, this is freaking me out. So yeah, expect some form of communication at some stage about this. So that's
happy to help.
I'm heading that way.
Awesome.
Cool. It sounds like you've got lots of people doing that though, so
yeah.
Conference talks and everything else happening soon.
Sounds fun.
Cool.
So Tony, are you good to go? Tony, are you there? Well, this is a little bit exciting. Note to finish on. So I'll just shout out to everyone that's presented today. And Tony will present next time. Thanks to everyone who's still there on YouTube. It's been great to have you. We might just have a wee chat on the GHO and we'll probably finish streaming live in a couple of minutes. So if you've got any questions, you've got a couple of minutes to flick them through. Or if any of our presenters want to have a wee chat, it would be great to hear if you've got any questions or any other stories.
Just a quick comment from me, Rachel and everyone else.